In this lesson, what we're going to be talking about is how you can determine acceleration based on forces. So we'll work through one problem and then you'll have an opportunity to practice them. So one student came up with a great idea of showing a scene from 21 Jump Street. So I'll go ahead and show that scene and we'll base our base our problem on that equation. Okay, so we'll end it there and actually work through the problem. Give me one moment. All right, so assume we take that scene from 21 Jump Street and put it into a Newton's third law problem. You have a car with a mass of 2,000 kilograms. It hits a person with a mass of 90 kilograms, and the force of the impact is 500 newtons. Can you determine what the acceleration was of the person of the car when it hit the person, and the person when it hit the car, and how much force there is? So let me go ahead and pull down my screen a little bit so I can use my tools. And we're going to work this through. These are relatively straightforward problems. So the first thing that you need to know or need to remember is that net force has to do with mass times acceleration. All right, so we do actually know that there is a net force of 500 newtons. And I know that because, again, in terms of my givens, 500 newtons is a force. Okay, and it doesn't say net force, but we're going to assume that it is. All right, the next thing is that I also have been given is I've been given 2,000 kilograms. And that is the mass of the person, of the car, make that into a car, and 90 kilograms, which is the mass of the person. Okay, so in that case, I know that thanks to Newton's third law, the force that these two hit have to be equal. So in other words, the car pushes the person with 500 newtons of force, and I believe it pushed him to the left. And so we can answer this question right over here. So thanks to Newton's third law, we know that the person pushes the car with 500 newtons to the right. Remember that Newton's third law is talking about every action has an opposite and equal reaction. So this is the equal part, that they're both 500 newtons of force. This is the opposite, one being left and the other being right. All right, so we're going to determine this based on the car. So it's asking what was the acceleration of the car. So my mass of the car, MC, was 2,000 kilograms. And I'm looking for acceleration. Acceleration being, excuse me, we'll see if we can keep on typing. Because we're going to pause for a moment. Okay, my apologies. And so I can multiply this by acceleration. All right, so how do I get A by itself? I divide both of these together from each side, and my acceleration works out to be 0.25 meters per second squared. So it's not accelerating a whole lot after it's hit the person. So my answer for here is 0.25 meters per second squared. Now on the other hand, what force did the car exert on the person? We know that it has to be equal. So 500 newtons. The car exerts 500 newtons of force on the person exerts 500 newtons of force to the car. What is the acceleration of the person when he hits? It's the same formula that we used before, but this time instead of doing the mass of the car, we do the mass of the person. We have 500 newtons of force. The mass of the person is 90 kilograms. And we're going to determine the acceleration. And here, again, to get it by itself, I divide both sides by 90. And when I do that, I get an answer of 5, an acceleration of 5 meters per second squared. And you do realize or see that the person is, when it hits the car, will move faster than the car will move, just because the person has a lighter mass. So our answer to this question is 5 meters per second squared. So that should give you the basic tools to work through the practice problems that I will be assigning for homework. Good luck.